In this video, I want to show you how to factorize a polynomial completely without using the long division, but using the synthetic method, which is a little bit similar. This is mainly for pure math students. Right, I'll take this one as my first example. Factorize f of x completely given that x minus 3 is a factor of f of x. Right, we don't use the factor in this method, we use the root. So let's find the root here. To find the root given the factor, we just equate the factor to 0, then we solve for x. So in this case, if we do that, we'll get 3 as the root. We are saying x is equals to 3. Right, then from there, we are now drawing these two. Just draw these two lines, two perpendicular lines. Right, then write the root here. X is equals to 3. Right, then from there, we now want to write the coefficients of x in descending order of powers of x. I am saying I'll start with this one in descending order, so I'll start with the coefficient of this x with the highest power. In this case, it is x to the 3. So I'll start with 3, the coefficient, followed by the coefficient of x squared, which is 1. In this case, it is 1, followed by the coefficient of x, and in this case, the coefficient of x is the whole of this number, minus 38, like this. Then finally, the coefficient of x to the 0, or a constant, which is 24. Now, okay, let me explain something here. If there is a missing term, for example, if this x is missing, this means the coefficient of x squared is 0. So for the coefficient of x squared, you write 0. Do not skip that step, that term. Likewise, if x is missing, for the coefficient of x, just write 0. Do not skip the coefficient. Right. Now, we now want to factorize, right? For a start, we just drop the first term. We do this operation from the right side to the we do this operation from the left side to the right side. Right, so we just drop this first term, this first coefficient as it is, which is 3, like this. Then to find the next term that we are going to write under 1 here, we multiply this 3 by this 3 and we get 9, like this. Right, to find the next term here, we are going to add 1 and 9 and we get 10. To find the next term under minus 38, we multiply this 3 by 10 and we get 30. Now, to find the next term under the next number under this 30, we add minus 38 and 30 and we get minus 8. Right, likewise, to get the number that we are going to write under this 24, we are going to multiply 3 by this minus 8 and we get minus 24. Right, then to find the last number here, we are going to add these two, and if we add them, we get 0. And this 0 is always the remainder. This is the remainder. This 0 is the remainder. So since this one is the root, then the remainder is 0. If it is the case that the question asks you to find the remainder after dividing f of x by a certain value or by a certain factor, just do this operation, then the number that you find here will be the remainder. So in this case, the remainder is 0, meaning that this one is a factor. Right. Now, we now have these coefficients. We have 3, 10, and minus 8. These are the coefficients of the quadratic factor in descending order of powers of x. I am saying this 3 is the coefficient of x squared, this 10 is the coefficient of x, and this minus 8 is the coefficient of x to the 0, or a constant. So our f of x is now, we can now express our f of x as a factor, as a product of this factor and this quadratic factor, like this. This original factor that we were given in the question. Then this 3 is the coefficient of x squared, this 10 is the coefficient of x, this minus 8 is the coefficient of x to the 0. Then from here we can now factorize this one further by just finding the factors of this quadratic expression. We are now factorizing a quadratic expression like this. The factors are 10x and minus 2x. Then let's factorize it completely. F of x is equals to x minus 3 factor of x plus 4 factor of 3x minus 2. Right, let's move on to the next example. Factorize f of x completely, given that 1 is a root of the equation, f of x is equals to 0. Given the root, then our life is now is, let's write the root here. Then let's draw these two lines. Alright, then from there, let's take the coefficients of x in descending order of powers of x. So this one will be the first coefficient that we are going to take. And in this case, we are saying the first coefficient is 2, followed by 7, followed by the coefficient of x squared here is 1. So followed by 1, the coefficient of x here is minus 7, and the constant is minus 3. Right, then from there we are going to drop this as it is. We get 2. To find the next number under 7, we are going to multiply 1 by these 2 and we get 2. To find the number under these 2, we are going to add these 2, and if we add 7 and 9, we get 7 and 2, we get 9. Right, the number that we're going to write under this 1 is the product of this 1 and 9, which is 9. If we add these 2, we get 10. 1 by 10, 10. If we add these 2, we get 3. 1 by 3, 3. If we add these 2, we get 0. And always remember that the last number that you get here is the remainder. That's always the case. Right, now these numbers are now the coefficients of the next factor. In this case, we have how many terms? We have 1, 2, 3, and 4. And this means this one is a cubic factor, not a quadratic factor. This one will be the coefficient of x to the 3, the coefficient of x squared, the coefficient of x, and the constant, like this. Our f of x is now a product of this factor, x minus 1, from the root. The root is 1. So if we reverse, if we take this one to the other side, it will be x minus 1. So the factor is x minus 1. If the root is 1, then the factor is x minus 1. Right. We now have the cubic factor. And we can't factorize this by grouping. So we are now going to apply the synthetic method for the second time. We are going to apply the synthetic method twice in this case. So let g of x be equal to this cubic function, this cubic factor, right? That's our f of x is now a product of x minus 1, this x minus 1, by the whole of this one, but the whole of this one is now g of x. So we're saying f of x is now x minus 1 factor of g of x. Let's look for the root by trial and error. Let's look for the root of g of x. Let's try g of minus 1. If we substitute minus 1 throughout, we find out that it simplifies to 0, meaning minus 1 is a root of the equation g of x is equals to 0. So since this one is a root, we are now applying the synthetic method for the second time. Right, let's draw the two vertical lines, the two perpendicular lines. Right, now let's write the root here. Then let's write the coefficients of x in descending order of powers of x like this. Like this 2, 9, 10, 3. Then as usual, the first one, we just drop the first one as it is. If we drop this one, get 2, then minus 1 by 2, it's minus 2. Then we add the 2, 9 plus minus 2, 7. Minus 1 by 7, minus 7. We add the 2, we get 3. Minus 1, the root, times this 3, minus 3. And if we add the 2, we get 0, which is the remainder. Now, this is now the coefficient of x squared, the coefficient of x to the 0. Now, g of x is now equal to x plus 1 factor of 2x squared plus 7x plus 3. And if we factorize this quadratic expression, we get x plus 3 factor of 2x plus 1. And g of x factorizes to these 3 factors. Right, but f of x is equals to x minus 1 factor of g of x. But this is g of x. So we are now saying f of x is equal to x minus 1 factor of x plus 1 factor of x plus 3 factor of 2x plus 1. Then we have factorized completely.